let's create an HDA for processing. New subnetwork. Great. We can copy from PDG these two nodes from visualization because we will need them now. So let's check the second output. If we check geometry spreadsheet, we have plenty of layers here. But if you look in the geometry spreadsheet, in primitive attribute, we have attribute PDG input file. So we can sort or filter the geometry based on that attribute. So let's create attribute promote. Original class primitive, new class detail. Original name will be PDG input file. Don't delete, change new. Let's name it like Max for now, or Max tiles. So let's insert for loop with feedback. Now select iteration 1. We will set later. And then create two meta imports nodes. And change the first one to fetch input. So let's PDG output 0 to feedback loop. So the operation will be added to this empty terrain. Each loop we will add some additional operation, and the second input, the process terrain, will be added into this feedback loop as an input. So we can put primitive wrangle and filter the geometry. And metadata to the second. So integer current iteration detail 1 iteration 0, and if attribute PDG input file senerovna is not sorry is not equal current iteration, then remove prim. 0, primnum 0. Or 1, so our points will be deleted too. But it doesn't matter because we will not process points, we will process volumes. And how many iteration? It's per input, attribute promote, number of iteration will be detail -1. How we name it? We name it max tiles. Max tiles first index +1 because the index is from 0. Okay, I check single pass. Perfect, it works. High field layer. First input here, second input here, third input here. Mask will be our merge mask. Layer mode will be blend. Layers, we will merge all layers except merge mask. We don't need it anymore. Not average, maximum. We need the maximum number, what is 8. So we have here 9 feedbacks. Now we have our terrain is perfectly blended together without any visible seam. It's just perfect. We can zoom this area. Perfect. No seam visible. And if we check, it's just one height, one mask, one playable area. Now we need to crop this terrain to final resolution. So we have our terrain size, so we can crop. It will crop. But if we cropped, we can see that we don't have anything because our center is at 0, but our processed terrain can be anywhere. So we need to find solution how to proper select where the center will be. We cannot use the actual center because, for example, in this case we can, because we have all cells around. But if we select area where we have only 4 cells, so it's the corner one, or we can select that one. If you can check that we actually need this one part, so the center of the final terrain can be anywhere. Terrain tile, and we can extract the center from this tile, because this tile has the correct resolution and correct position. There is no voxel padding. There is some voxel padding, and there can be even more. We size multiplied by 1.3. Attribute create, spare input, select mask helper. I prefer this method because I know what node I am referring to, and we will create 2 attributes: center X, center Z, detail attribute, type float, and we can use centroid function -1 d underscore x and centroid -1 d underscore z. So we have our center position stored in detail attribute as well. Let's unconnect. Let's dive inside. Terrain pipeline. Let's select delete this node output files. Accept. Dirty cook this node. Let's wait until it cooks all the datas. Another important, if you, let's say, see some tiles not processed during this cooking, we can just select the generation tab and the generate work item not automatic, but when, for example, each upstream item is cooked. So the next work item will be created when the previous one is processed. So it's you can be 100% sure that this work item will not flow through the process unprocessed by the HDA parameter. What can happen? So that's each upstream item is cooked. Let's dive into terrain partitioner, and this geometry import node generate when all upstream items are cooked. So this geometry import will process when all work items are processed. So it will load all geometry at once. The second one, all upstream items are cooked. So we can be sure that this sorting and selecting and the importing, this one, two, each upstream item is cooked. Each upstream item is cooked. So we will have correct data. Okay, go back. So HDA. Now we can use these detail attributes. So size will be correct, and here will be detail 0, attribute center X 0, Control C, Control V, center Z. Perfect, it corresponds. Okay. So let's connect first here, second here. Not, second will be connected here. Okay. Merge terrain, create digital asset, merge terrain, merge terrain. Okay, create. Two inputs. One output. Apply, accept. Terrain pipeline. We can copy this HDA processor. And here you can see we don't have two inputs into this HDA processor. But if you click one dot and work item info, you can actually see that we have there two outputs. So don't be scared. We have two inputs. And because this partitioner by node is select sort by nodes by input index, we are 100% sure that this empty terrain will be at the beginning, so it will always go into the zero input, and this will be in first. So don't be scared, it will works. Okay, let's select our merge terrain. Merged terrain. Okay, I figured it out. We have to specify just file tag here, so it will process every both it will process both branches. Like, check the result. PDG visualization. We have just one output. Perfect. Here we can select merge terrain. So it will start at 0. Parameter. Paste relative reference. Okay, so it's first input. We have 72. Should work. I figured out that our merge mask is not 0 to 1, it's slightly off. We can put remap, and if we check select the merge mask, compute range, you can see that it's slightly off. So to fix that, we can either put this at the beginning where we created it, or we can just go and put the node here. So during blending or height, it will use the remap web merge mask. Okay, so I will just put it at the beginning. Right size, then project let's check it here. Compute range, mask, compute range, yeah. Clump minimum, clump maximum. So result is perfect. So in the next lesson, we will continue to build our world.